Okay, question 5 then. We are getting there, folks. Question 5. And what this one says is, find the gradient of the tangent drawn to the curve at the given point. Right, try and picture this a little bit. So you've been given a curve, y equals x plus 2, which is essentially going to be something a bit like x squared add 2x. That means it's a smiley face. And they've drawn a tangent to it at the point minus 2, 0. Okay, so at minus 2, 0 on there, what they've given us is they want us to find the gradient of the tangent. Now, that means that a line drawn on here somewhere, touching at one point, they want to know the gradient of that. So before we get bogged down in the details, let's just differentiate, because that's the first mark whenever you hear that sentence. Gradient of a tangent to a curve, 2x plus 2. So we've done that, and they wanted us to find this at the point where minus 2, 0. So if I put minus 2 into this, when x is minus 2, the gradient is 2 times minus 2 add 2. I get out, believe it or not, minus 4 add 2, I get minus 2 out of it. Now, what that means is, at minus 2, 0, at this coordinate, wherever that may be, possibly over here somewhere, the gradient of the curve at that point is minus 2. What does that mean in terms of this tangent? Well, if we drew a tangent to it, and remember the tangent touches it at just that point, that means if the tangent touches the curve at just that point, it too has a gradient of minus 2, because at that point the curve's gradient is minus 2. So what we're saying, 1 mark for expanding the brackets, 1 mark for differentiation, 1 mark for substitution, and 1 mark for your gradient. So it's 4 marks on all together there, people. Let's do 5 part B. It's a similar type of idea. 5 part B. And the graph they're talking about this time is y equals root of x. Now that's a funny looking thing. I'll sketch it over here for you. And it looks a bit like that. It's not a log, so don't get confused. It's nothing like a log. It's a bit like that. Now at the point 4, 2, which is about here somewhere, what they're saying to us is, what's the gradient of a tangent drawn to it there? So if I drew a tangent there, right, what's the gradient of the tangent? Well, it's the same as the gradient of the curve at that point. So prepare it for differentiation. Oops, you can't see it really. Prepare it for differentiation. dy by dx equals half x to the minus a half equals 1 over 2 root of x. Now I'm jumping a little step, but you've seen it a few times now, hopefully. At x equals 4, the gradient equals, well, this is why I'm always saying get rid of the fraction powers, get rid of the negatives, because it's dead easy to sub into this, isn't it? Look at that. It's 1 over 2 times 2, which is a quarter. So at that point there, the gradient's a quarter, which means the gradient of our tangent is a quarter. Where are the marks coming from? 1 mark for preparation, 1 mark for differentiation, 1 mark for tidying up, 1 mark for subbing in, 1 mark for your final answer. 5 marks.